Right, I thought we'd learn FreeCAD together. So, you might be wondering, why on earth aren't we looking at a computer screen or I was sitting in my back garden with a cup of coffee if what we're going to do is learn FreeCAD? Well, that's because it's like a jigsaw puzzle. I mean, I could just pour out all the pieces on the table and point the camera down and say, make that jigsaw. And of course you could do it, but it would take you forever and initially you'd be lost. One of the easiest things to do is turn the box lid over and look at the big picture. And that gives you an idea of where it is you're heading. And that's super important whenever you're completing any puzzle. And of course, learning a new program is really just completing a puzzle. And the first question you have to ask yourself is, what is it you're doing? I mean, people go, I'm learning FreeCAD, turn the computer on. But you're not learning FreeCAD. You're learning to see in a certain way. All programs are written with an objective in mind. I mean, a CAD program is written to draw in 3 dimensions. And so it's going to have certain things in there that help you do that. They will mirror the real-world experience. They must do. And they must have those things in there. Otherwise, they would be useless as a CAD program. So, what is it in the real-world experience that we're doing when we're designing a mechanism or a thing? Well, here's a bit. This is a escapement mechanism with a spring motor attached to it. And it's relatively complex when you look at it as a whole mechanism like that. But we can break it down. What we can do is remove this. And if we remove that, which is one of the parts of it, then clearly we have a part. So the first thing that we're doing is we're taking a mechanism and breaking that down into parts. When we break it down into parts, we can look at the part and say, how was that put together? Of course, if you look at this, all it really is a couple of, circles and a couple of rectangles and a couple of part circles all lined up and then thickened out. So we could shrink that down to a drawing, an actual drawing, and draw out the circles that we need and then stretch them up and we would get our part. Now, here's the big surprise. All CAD programs do exactly that. And when you're wanting to do that, of course, if the CAD program didn't do that, it'd be next to useless to you. So when you look at a CAD program, what you're looking for are the abilities to do that. And they're arranged in what are very often called workbenches. And it's that scenario of being in the garage and moving from bench to bench. When you look at something like FreeCAD, here's a big surprise. It's arranged in workbenches. To get FreeCAD, just type in FreeCAD, it'll pop straight up and click on it and it'll take you to the download page. Download now and you'll have a choice of what you can download it for. It's got Windows, Macs and Linux, and just click the installer and that will download it for you. Once you've downloaded it, jump to the folder you've saved it in and double click it and follow the install screen. Right, when we've installed it, this is the start screen that we get. And now you can fiddle on with this if you like. Most of it I'm okay with, actually. There's your language choices, got a billion of them, and we've got our unit systems. I'm multilingual in units, so millimeters or inches makes no difference to me. I'm going to leave it at millimeters. This is kind of interesting. I'm actually working on a laptop, so I've got it touchpad so I can navigate it, but you can mimic other programs you might be used to using on how you navigate around those. We'll leave it at touchpad. Incidentally, if you scroll down to there and just let the thing hover over, then you'll get little navigation style clues that help you actually remember how to navigate around. If we go up to edit, then we can change the preferences later if we want to by clicking on preferences. I'm just going to leave it like this on FreeCAD Lite. Obviously, we go to File, and hey, how about that? Click on New, and we get ourselves a new workspace. Now, I talked about this idea of workbenches. The idea being that when you're at a workbench, all the tools to do that job are presented for you. And here they are, these pretty pictures. If we hover over one, a pull-down will come and tell you what that one actually does. If we hover over this pull-down menu here, we can see it says switch between workbenches. Click the down arrow and those are the available workbenches, and there's a whole range of them that's pretty impressive. Assembly, well, what it says on the tin. One of the ones I'm interested in is CAM, because I want to be able to use that CNC machine. You've got FEM, which is finite element modeling, where you can look at the stressors, but the two we need to focus down on are part design and Sketcher. Now, these workbenches do talk to each other. The whole job of them, really, if we click on part design, is to present you with tools you need to design the part that you're working with. Right, let's have a quick cup of coffee and a review of what we've done. We've learnt where to get FreeCAD from, how to install it, how to set it up, and how to open a new file ready to do our drawing. Now, all of this stuff can be changed. If you go to Edit, Preferences, you'll have a pull-down menu box where you can change all of these preferences. It's one of the reasons you don't need to worry about this stuff. My contention is getting started with something isn't about learning what everything does, it's about learning what to ignore. As you get better at it, of course you're going to want to make some of those changes. You don't need to make those changes now to get you up and running. To get you up and running and learning how to use something is about using something and changing those later. So all of that stuff can be changed in the preferences. To navigate around it, of course, we've already seen that. I set it to touchpad, you hover over there and it'll remind you how to zoom about the screen, rotate and zip everywhere, and you've got the little box in the corner, and it won't be very long, I don't know, 10 or 15 minutes before you don't even need those reminders and you're zooming around the thing. The answer is to explore and ignore most of it. Right, we're ready to create a part. So the thing I want to make is this. It's actually a high reduction gear ratio gearbox. This particular one is 20:1, and like all mechanisms, we can pull this apart into the parts. If we do that, what we've got is a clip, a handle, we have the top drive plate, if that will come off, there we go, top drive plate. Then we have a drive gear, an eccentric to drive it, the driven gear, axle, handle. I want to make that in aluminium because I thought that was really cool the way it worked, but it was only 20:1 and I wanted to make something at 60:1. I want to use it in a clock as an example, or maybe as a NEMA stepper motor driver, something like that. But I thought I would shrink it down, make it in metal and see how the thing actually works. So that's what I'm aiming for. We have a mechanism and we've broken it down into parts. Now, of course, what we need to do is reproduce those parts. And what I want is something about 3 or 5 millimeters deep. This one is 120 teeth, so I'm going for a 60:1 gear ratio. That's 120, that's 122. That'll give me a 60:1 gear ratio, and it's really just the same as that, but a finer tooth. And of course, the metal can cope with the finer tooth. The plastic will probably wear with the finer tooth. So I've done a finer tooth, many more teeth, and that is one of the parts that I'm going to need. And that's how we break these things down. We have a machine. A machine is made of mechanisms. We break the mechanism down into parts, and it's the part that we're looking to draw and manufacture. Now, in FreeCAD, the way you look at parts is as drawings from a different direction. So if I look at it that way, I have a flat drawing there, and I need to draw that out in FreeCAD. Once I've drawn that out, I can look at it that way, and because there's nothing here, I can just stretch it in that direction, and obviously that will give me my part. So FreeCAD breaks it down in that step by step, and you'll see that in the workbenches. And if we get to the very basic step, which is essentially drawing sketches flat of the shape that you want, extruding them, and then if you want something else here, you have another flat sketch in that direction that you then extrude, and you build that up into what they call a body. So a body is just a container for the elements of a part. You put the elements of a part in a body, and then when you've finished combining everything, you get your part. Right, here we are with FreeCAD nice and freshly opened. Let's create a new file. There we go, new. And it's unnamed at the moment. We could name it if we want to, but nothing I'm doing here is particularly complicated. It's quite straightforward. But the first thing you probably would do is create a part. And here, if I hover the icon over the part, we'll see it's a part is a general purpose container. It keeps all the objects together and it's added it to this tree. So under file, we've got our first part there, and that part will keep everything nicely together. If I created another part, it would still be in the same file, but all of the work would be on a different part. And here we're going to create this part, and we can use that to be a container for everything that we want. Now, the part itself isn't complicated, but some parts are. And here, if we're going to work on a section of the part, we can create what's called a body. You'll notice that both the part and the body are bold. When they're bold, they're highlighted so that we can work on them. And what we now need to do, we've got the body, is we need to create the sketches. Here we've got origin. There's an eye icon to it. If I click on the eye icon, we can see the planes spring into view. We create the sketches on the planes, as I discussed earlier. The plane that I'm going to use is this one here that's kind of like the same as on the desk, the XY plane. And I don't really need to see that. I need to know that I'm doing it and where it is and which plane I'm working on when we're working on a particular body, because we can work on a body in the XY or the XZ. We can combine them into that part. But we're going to work on this particular body here on the XY plane and, the XY plane, and create some sketches. Let me just hide that again. There we go. Now, as I said, it's all on sketches, but FreeCAD does provide you with some pre-made sketches. We're in the workbench part design, and we also have a menu here called part design. Click on that, and if you scroll down, you'll see a ready-made involute gear for you. So we just need to click on involute gear, and it will pull up a gear. This is jolly handy because it saves us an awful lot of trouble trying to work out what those tooth profiles are. We've got some parameters we can set. So the first one, remember I said it was 120 teeth, so I can change 120 teeth. Then we've got the module. Now the module is the relationship of the tooth number to the pitch circle. It doesn't really matter. What's interesting is we can set it as an actual physical value. Here we've got 2.5. Normally in Tinkercad I do 2 millimeters, but we can also set it as a result of a formula. So if I blank over that, and I want my gear to be 100 millimeters wide, then I can specify it as 100 millimeters and divide it by the number of teeth. What will happen there is it will work out the module for me, given that formula that I just put in. If you remember in video 2385, that pressure angle needs to be changed to 30 so that we can make it slack enough in order to rotate around an inner ring gear. Now this precision, we can choose true or false for it having high precision, and the other interesting one is external gear. Here, if we choose true or false, it will change it from being an external gear, a normal spur gear, or an internal gear where we can use it to make a ring gear. Either way, once we apply all of that and click OK, then we have created our involute gear. Now, there should be something you noticed. We're on the models view here, and we're having a look at the model at this section here. Here, we've got task, and we jumped to that when we were setting up the sketch of the gear that we wanted to produce. So if you jump back to task, you can see that there are no tasks left because we've done them all. Now what we need to do, of course, is create those rings in the center, because this is just going to be flat. All we're going to do is extrude it, and we can extrude it by being on involute gear and clicking on pad. When we click on pad, it will jump to the task bar because it's telling us that we have a task to complete, and what we need to do is finish the pad parameters. Here we can see the pad is at thickness 10. I want 5 or maybe 3. Enter that, click OK, and it will create a solid for me that is an involute gear. And there we go, we've created our gear. Now that gear, of course, needs things like axle holes and it needs the drive holes that we put in. In order to do that, remaining on body, what I actually do is create a sketch. Now this is going to be a hand-drawn sketch. This is still a sketch. It's a sketch that was provided by FreeCAD to save us trouble. We need to hand draw a sketch, and so we go to the create a sketch. We create a sketch and it will add that to our model, and you'll notice we now have a task, and that is to choose the plane. And remember I said I want it in the XY plane, so let's choose that as the XY plane and click OK, and that's our task for doing this complete, and it will add it to our model. Of course, there's nothing in the sketch. I need to add things, so the task there is telling me to add things to the sketch. Close it, and if I take pad and make it unseeable and click on sketch, what I'll get is the sketch profile where I can add bits and pieces to it. So once I'm in the sketch plane, what we got is a blank page. So let's make the origin reappear by clicking the eye, and we get the XY plane and the X and Y axis. But there's nothing to draw with. If we look at these tools, there aren't any tools to do a sketch. That's because we're on the part design workbench. We need to move workbench. You've got to think of it like you need tools. The tools are on a workbench. You have to pick up the part and walk to the next workbench, plonk it down. The part doesn't change, the tools change. So click that down arrow and go to the Sketcher workbench, double click on sketch, and all of a sudden we've got an empty sketch, as we know from tasks, but we've got all these drawing tools now that we can use to create our sketch with. And what we want to do is create a load of circles. So we're going to create circles by center. Click on that. As you go down, it will show you the sketch icon for the sketch tool that you're using, which is circles. If you right click on it, that will disappear and it's gone. We need to left click on it again to get that tool. Once we go into the center of it, and you can see the center is marked 0, 0, we can increase some circle. Now, to be honest, this is probably one of the things that really annoys people, because you can't just draw a circle. What you need to do is draw the circle and add constraints. FreeCAD needs constraints on everything, and adding constraints in the right way, people find frustrating. But as long as you're logical about it and you add the constraints, you'll be able to create the shape that FreeCAD can understand and then use it. Now, I've actually put that circle in and it has a ready-made constraint, and that constraint is diameter. I want this to be 20 millimeters across, so just type in 20 millimeters, hit enter, and we've created a circle with a single constraint, that is diameter. We've also created it, however, at the origin, and it's placed the origin locked. So if you look here on the taskbar again, what we've got is this fully constrained. And whenever you draw something, it needs to say fully constrained. Here, we've got the constraints we added. We've got the locking constraint to the center, which it added by itself, and we've got this constraint, which is a diameter, which is what we added. Now, of course, what we want to do is create a whole load more circles that are going to engage with the drive. Now, you can think of constraints as a description of the object you've just sketched. Now, in Tinkercad, you don't really need that because, you're basically making an STL model that you're going to print. But in something like FreeCAD and other CAD design programs, you can actually do an awful lot more with it. I mean, one of the things you can do is model with it. You can create parameters for friction or pressure or whatever it is you want to do, and do an analysis of things like magnetic fields and temperature, that sort of thing. But in order to do that complicated stuff, FreeCAD and other CAD programs need a full description of what it is that you're putting in there. A full description includes things like where is it located, how big is it, what kind of shape is it, and how does it relate to the other shapes. And those are the constraints. They're the things that you put in to describe that shape, its location and position, its size, and what kind of shape it is. So that later on, if you want to do those other things, then they're easy to do because you've fully defined the shape. Now, if all you're going to do is create models through 3D printing, of course, it's a bit superfluous. But one of the main reasons we're doing this is because we need to use that CNC machine, and so we need a full description. That's all constraints really do. If you don't constrain something, that is, describe something fully, later on it's going to fail and you're going to have a problem. So this forcing you into describing things fully and letting you know by saying fully constrained actually is a help. It's a help a lot later on down the line. But it is a bit frustrating when you're first picking it up, trying to find out where on earth you haven't put a constraint and it's telling you to put a constraint. So the idea would be, don't bung all of your drawings on at once and then try to constrain them, because honestly you'll just get lost. Add the elements to your sketch as you go along and make sure they're constrained as you add them, and then you'll find that the whole sketch becomes fully constrained. Now, another option here is never to make a sketch too complicated. If you put a billion items on a sketch, trying to do a whole machine out of it, you're going to lose track. Remember that process of breaking down a machine into a mechanism, into a part, into 3-layer sketches, and it'll help you to keep a track of what your constraints are and make sure you've put the constraints in. Later, that's going to help tremendously. Right now, I think people find it hideously frustrating. Right, back to our drawing. Now, obviously, we've got to put 8 more circles in there, and they're going to be the same size. Of course, there's loads of ways of doing this, but one way I thought was cute is if we highlight the circle, so it's highlighted here in the elements, and it's gone black here on the screen, is to copy and paste it using keyboard controls. So if we had Control C and Control V, it will copy and paste that circle. Now we've got 2 circles here, as we can see in the elements, and if we remove circle 1, our original circle, just by hiding it, then what we're looking at is circle 2. Now, because it's copied and pasted, it's still fully constrained, and here we have constraint 1 and 2 that apply to circle 1, and 3 and 4 that apply to circle 2. 4 is the one that locks it to the center, so let's delete that by just deleting it. If we delete that, then it will become under-constrained by 2 degrees of freedom, and circle 2 now can be moved anywhere we want to. So if we move it out of the way there a little bit, and bring back circle 1. We can't move circle 1. It's nice and green, and if we try to highlight it and move it, it's going nowhere. This one, however, although it's constrained on its diameter, could be anywhere on the XY plane, and we want to constrain it into one position, and that's directly above this circle here. To do that, we can use the dimensioning tool, this one here. If we hit the down arrow, we'll get a selection of dimensioning tools. If we just hit that, then it will do automatically what it wants to do. Click on the center, and it'll find the nearest line, which just so happens to be the distance to the axis. Right click on it, and then we'll set that at 30 and click OK. Now it's going to be constrained to be 30 millimeters center to center above that. But equally, of course, it's now too far out, and it still has 1 degree of freedom. So we can use a dimensioning tool again. If we use it on this center here, and we dimension it to this edge here, it'll automatically do it for us. And if we hit 0 in there and OK, now it's directly above there, and we can see it's fully constrained exactly where we want it to be. If we want to repeat that, then we hit the second circle. So we're going to copy that one. Control C, Control V. It will copy it into circle 3, and this time, of course, we have a different set of constraints. And there's a constraints here in constraint 6, 7, and 8. If we change that one, and we can do that just by double clicking on it and make that minus 30, it'll drop it directly below. Even better, the whole thing is fully constrained. And we can do that for all the other circles just by changing the position in that constraint, because that constraint, by double clicking on it, can be changed. And when we've done that, we get our circle sketch in the center with 8 identical circles evenly spaced around it. We get this whole bunch of constraints we've basically just copied. And the most important thing, it's fully constrained. And now we hit close. Right, we're still in Sketcher, so we need to go back to the part design. And when we do that, of course, it changes all of these tools. And we're going to need that one, which is called the pocket tool. Why they call it a pocket for drilling a hole in, I don't really know, but they do. If we actually click on the model, we can see that we've got Sketch here, and we make a pocket out of that, and it'll create a task for us in a second where we'll get some pocket parameters that we can actually set. As you can see here, we've got it at 5 millimeters, which is the depth of the extrusion of the gear that I did. However, the pocket goes down, and we've put everything on top of the XY plane, so we need to reverse it, and we click OK. Now that task is done, and hey presto, it creates all the holes and circles in the surface and through the body of our gear that we're going to use. So make sure the part and the body are active, click onto File and Export, and then we'll get a choice of what we want to export it in. And there's a billion of them. And you can see we've got OpenCAD, step files, STL files, all kinds. We're going to do as an STL mesh because we're just going to 3D print this at this stage, and then obviously click Save and it will export it. And when we print it off, that's what we get. Right, now I know I took quite a long time to do that actually, but I think that's important. I mean, we're not penguins pecking at buttons waiting for a sardine as a reward, and I have watched people zip through some of this stuff thinking, crikey, what on earth did they do there? I think it's more important at the early stages to understand what it is that you're doing and why you're trying to do that. Because if you hit something unexpected, well, then you can just work it out. If you're following button presses and something unexpected happens, to be honest, you're a bit stuffed. So for me, understanding what it is you're doing is far more important. The operations of how you do it, well, there are tips and trick videos out there. There are things you'll discover yourself. It's actually a matter of just getting on there and doing it. The hardest thing is understanding what it is you're doing. So remember, we take our machine, it's assemblies of parts. We take our assembly, it's a part. We take our part, it breaks down to sketches. We make the sketches in FreeCAD, making sure it's constrained. The whole lot's kept together because it's basically one thing we're working on different workbenches, and then we'll get our model. Exploring the toolbars and what kind of constraints you put in, that's practice. Give it a go at doing something because you now know what it is that you're actually trying to do. And like I said, for me, that's much more important than a few tips and tricks. Tips and tricks are awesome, and I have watched a few tips and tricks, but it's much more important to my mind to understand. Now, I hope you enjoyed the video. I hope it was help because we will be moving on from this and I won't be going so much into depth about why it is you're doing what you're doing in future videos. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.